module 2.3, division with fractions. So in this lecture video, I'm going to do a lot of examples on division of fractions. Now, before we do any example, let's take a look at the concept of reciprocals. The reciprocal of A over B is B over A. So most of the time when we say the word reciprocal, simply means we flip the fraction. The product of a non-zero number and its reciprocal is always going to be 1. Okay, so when we talk about the identity property of multiplication, okay, like if I have a 2 times its reciprocal will always equal to 1. Okay, so basically we are talking about the reciprocal of any number, okay, times itself or times whatever it was will always equal to 1. Okay, the product of a non-zero number and its reciprocal, when I multiply them, is always equal to 1. All right, make a note, 0 can be 0 over 1, but 1 over 0 is actually undefined. So 0 does not really have a reciprocal. Okay, so it turns out there's no, when we're dealing with fraction, we actually don't divide it by a fraction. Instead, we will times by the reciprocal. So to divide any non-zero number, we will actually multiply by its reciprocal. Okay, so division of a fraction, just remember, times by its reciprocal. So, for example, 41 over 45 divided by 41 over 40. So our first fraction stays the same. Division of another fraction means times the reciprocal. So the first thing I do is to write times the reciprocal. So now I'm turning a division problem into a multiplication problem. So once I become multiplication problem, then I'm going to reduce my top numbers with the bottom numbers. So quickly I noticed 41 on top, 41 in the bottom can be reduced by 41 itself. That will give me 1 and 1. Now the 40 on top and the 45 in the bottom, I recognize them under the multiplication table of 5. So if I reduce them by 5, that will give me an 8 and a 9. So that's it. No more reducing top and bottom. 8 and 9 cannot be reduced, so multiply them side by side. My answer, 8 over 9. Okay, so division of a fraction means times the reciprocal. The first fraction always stays the same. So this 7 over 20 stays the same. Dividing by 18 over 9 means times the reciprocal, which is 9 over 18. Alright, so once I become multiplication of fraction, I would take my top number, reduce with the bottom. And here I notice my 9 on top and 18 in the bottom can be reduced by 9. So that gives me 1 and 2. So I just wrote a 2 down. 2 cannot reduce with the 7 on top. So there's no number to reduce top and bottom with. So let's multiply them side by side. 7 times 1 is 7 over 20 times 2 is 40. Okay, that would be the answer. All right, now if I need to divide it by, if I take a fraction divided by 2 more fractions, okay, then both those fractions will turn into times the reciprocal. Only the first fraction stays the same. So this 2 over 5 stays the same. Divided by 17 over 16 means times the reciprocal. That's 16 over 17. Cannot reduce before you write them as multiplication of reciprocal. Alright, now let's check it. 2 on top, 16 in the bottom, 5 in the bottom, 17 in the bottom. 2 on top, 16 on top. Cannot reduce with anybody down here. There's no common factor other than 1. So let's multiply them side by side. 2 times 16, 32 over 5 times 17. 5 times 7 is 35. Carry 3 on our finger. 5 times 1 plus 3 is 8. So my answer, 32 over 85. All right, dividing by a whole number or a whole number divided by, either way, as long as I'm division of a fraction, I will always remember to write times the reciprocal, which is 1 over 3. All right, so now once I become multiplication of fraction, I can reduce the top with the bottom. So I notice 15 and 3 can be reduced into 1 and 5. So 5 on top, 8 in the bottom cannot be reduced. So that's 5 times 1 is 5 over 8 times 1 is 8. All right, just a few more examples. Same thing, doing the same thing over and over. Division of a fraction means times the reciprocal. So that will be times by 33 over 17. So at the same time though, I'm constantly showing you how to reduce a top number with a bottom number first before we multiply. 7 and 17 are both prime, so they cannot be reduced. The only number I can reduce is 33 with a 15, because I recognize 15 is under 5 and the 3 for multiplication table, and it just happened 3 can also go into 33. So if I reduce a 15 and 33 by 3, that will give me 11 on top, 5 in the bottom. So now all 4 numbers are prime numbers, so they cannot be reduced. So let's multiply side by side. 7 times 11 is 77 over 5 times 17, that's 85 again. That will be my answer. All right, let's take a look at this one. Dividing by 44 over 28, so that's 17 over 34 times the reciprocal, 28 over 44. Let's think about this. 17 and 34. Isn't 17 times 2 is 34? Yep. So 17 and 34 can be reduced by 17. That's 1 and 2. 28 and 44 can also be reduced by 4. That will be 7, right? 4 times 7 is 28. 44 divided by 4 is 11. So that's it. 7 to 11 cannot be reduced. Top and bottom, so that will be 7 over 22. All right, one last one. Dividing by this one and that one is almost similar, because dividing by 30 over 27, I can write this as 19 over 38 still, times by the reciprocal, 27 over 30. And I know 19 times 2 become 38, so 19 and 38 can be reduced by 19. That gives me 1 and 2. 27 and 30, top and bottom, can be reduced by 3. No. 3. That will give me a 9 and a 10. So 9 and 10, consecutive numbers. I forgot to mention before. Consecutive number, top and bottom, can never be reduced. Not like 9 and 10, 7, 8, or 8 over 7, or 10 over 7. None that can be reduced. Consecutive number cannot be reduced, top and bottom. So now 1 times 9 is 9 over 2 times 10 is 20. Alright, so this lecture video, we quickly talk about how we divide by a fraction. Means we will write times the reciprocal. Make them into a multiplication problem before we reduce top with the bottom. That will conclude this lecture video. Thank you for watching.